Here we are in the chapter review exercises for chapter 5. Factor the following numbers 28 through 33. So we're factoring. Here are the methods we've had. So 28, do we have any common thing? We do. We have a 4 that we can take out of everything. We have 2a plus 2b minus bx minus ax. Looks like. Okay. So we have 1, 2, 3, 4 terms left, which means we're doing grouping on this leftover piece. So we have, let me see, chainsaw that guy, and we can take a 2 out. We have a plus b. Take a minus x out of the second half, and we have b plus a. B plus A plus B, those are the same thing. Yes, indeed. So I'm going to rewrite this guy as A plus B. So they look exactly the same, so we can now take him out. And we have A plus B out front and 2 minus X right there. Oh, and don't forget this 4 has to come down and sit right in front. And there we have it. Number 28. Number 29, greatest common factor. Looks like a y squared can come out of everything. So y squared, and we're left with y squared plus 2y minus 35. What's left is a trinomial leading coefficient 1. So we're right here on method 3. Put the y's here and the y's here. What times is to a negative 35? Let's write it up here. Negative 35 could be a 1 and a 35 or a 5 and a 7. Oh, it looks like a 5 and a 7 are the ones with a positive on the 7 and a negative on the 5. And y squared just sits out front. Excellent. Number 30. 9 minus 16z squared. Is there a common factor at all? There's not. So we look, how many terms? 2, so we're down here 5 in the specials. Do we have perfect squares? Yes, 9 and 16 are indeed perfect squares. So we have, yeah. Oh, that means it's just one step. We take square root of 9 is 3, and square root of 16z is 4z. And we have one of them as a plus and one of them as a minus. And we're good. All right, number 31. No greatest common factor. Looks like there are 2 terms, and we look. 64 is a perfect square. It's 8 squared. But you'll notice this is not a perfect square. That's a perfect cube. So we need to think, is 64 a perfect cube? And it is. It's 4 times 4 times 4. So let's, ooh, yeah, okay. So we've got to follow this one right here with the minus sign. So we're following the minus here and the plus over there. We have t minus 4, and then it's a squared plus ab plus b squared. And you can look to see if this, anything times this to 16 adds to 4 to see if this polynomial will factor anymore, but it in general does not. Okay, number 32. 64x cubed and 125. This is a perfect square, but that one's not. But they are both perfect cubes. Again, 64 is 4 cubed, and this is 5 cubed. And there are 2 terms, so we are indeed right here again, but this time with the plus sign. So we're going to have a plus and then a minus. We'll follow the top signs. So we have, let me see, 4x plus 5. So again, the first half always matches that sign. And then the second half, we have a squared, so that's 16x squared, minus, so it's going to be the opposite sign of what was in there, which is minus 20x, and then plus b, which is 5 squared, 25. And again, you can try to break that down more, but in general, it will not. And the last one, 8q cubed minus 1,000. 8 and 1,000 are both perfect cubes. We have 2 terms. Oh, hold off. Whoa, I almost just messed up. Don't forget this guy right here. Can we take out a greatest common factor? We can. 8 factors out of the whole thing, gives you q cubed minus 125. That almost tricked us there. So now this is a perfect cube, and this one is also a perfect cube of 5. So we get 8. Let me see. So we'll be doing this guy right here with a minus sign. So that is q minus 5. And then a squared, so q squared plus ab. That's plus 5q, and then plus 25. All right, there's 28 through 33.